It says here, the framework for a construction consists of a cyclic quad. Now, folks, the cyclic quad is PQRS. Now, immediately we're going to stop reading. We're going to say, okay, if this angle is 2x, the angle that lies opposite to it is the sum of those two will be supplementary. So that angle will be 180 degrees minus 2x. Opposite angles of a cyclic quadrilateral is supplementary. So we've used the cyclic quad. It lies in the horizontal plane. There's a vertical post at TP, which is the reason why this is a right angle, because vertical stands perpendicular to horizontals. From Q, here's Q. The angle of elevation of this tower to T is Y. So if that is Y, then this will be 90 degrees minus Y. If I needed Y, is that so? The complementary angles. Those two angles are complementary because they add to 90. Okay, then they tell us PQ, which lies over here, is indeed equal to PS, and they are both equal to K. Okay, so we stop reading over there. We'll go for the rest just now. What can I say here? I have an isosceles triangle PQS. The sum of the angles in a triangle adds up to 180. And this angle here at P is 180 minus 2x. That means these two angles here, they will be equal to each other because they lie opposite equal sides. But the point is that they're both an x, because together they need to give me 2x, this 2x over here. So I divide that by 2, and I have my two base angles. Don't make a mistake and say it's 90 minus x. So don't go and divide the 180 minus 2x by 2. That is a catch here because of the opposite angles in the cyclic quad. Then they tell us TP is 3, so the height of the tower is 3, and then they just confirm that SRQ is 2x degrees high, so 7.2.1. I think we've already answered that. Giving reasons the size of SPQ, or PSQ rather, this angle over here. Now we've seen it's x. So we're going to say PS is equal to PQ is equal to K. Why is that the case? It was given. So therefore, angle PSQ is equal to angle PQS. And the reason is angles opposite equal sides. Those are equal. But now we're going to say, it's for 2 marks, but SPQ is 180 degrees minus 2x. Opposite angles of a cyclic quad is supplementary. Okay, and then finally, the angles S down here, that angle, is equal to angle Q is equal to x. That's a bit of our reasoning that happens over there. We use the fact that we're working in an isosceles triangle. That's fact number 1. And fact number 2 here is that we have a cyclic quad of which the opposite angles were supplementary. Okay, so that was quick. So 7.2.2 for 4 marks. Show that SQ, we've got to show that SQ is 2K cos x. Okay, so now let's see. SQ is this side on our diagram. I have those two sides. I have the opposite angle, and I want this here. So yes, I think let us go for the cosine law. Let's see if the cosine law works. Cosine law works with side included angle, and that's what we've got. So we're going to start, we're going to say, okay, SQ squared is equal to K squared over here. plus the other k squared minus 2 times k, which again is k squared, cosine of the angle, which is 180 minus 2x. Now we know by our reduction rules that that's a second quadrant angle where cosine is negative. So this becomes 2k squared cos 2x. K squared plus k squared is also 2k squared, and that is still equal to sq squared. Now folks, the trap here, and I've seen this happen every time I mark matric papers, is that you guys forget that that is multiplied with 2k squared. So some people will say this is 4k to the 4 cos 2x. You can't do that. Okay, you must first remove the 2k squared and work with what's left. This here is multiplied. So if I remove the 2k squared, then I'm left with 1 plus cos 2x. Now, folks, remember that's where we're going. Okay, we're going to that component. We're still on sq squared. So if I look at this sq squared and I keep the 2k squared for the moment, I can't get rid of the 1 unless I turn this into its double angle. The double angle, why? Because there's no 2x in the answer, there's an x. Okay, and the answer does not have a sine in it, it has a cosine in it. Now remember, you've got one of 3 choices for the cos of 2x. The cos of 2x is cos squared x minus sine squared x, that's 1. The second one is 1 minus 2 sine squared x, and the third one is 2 cos squared x minus 1, which is the one we're going to go for. So we're going to say this is 2 cosine squared x minus 1. We've expanded that double angle, and look at how beautiful this now cleans itself up. I've got 2k squared plus 1 minus 1 is 0. 2 cos squared x, I multiply in 4k squared cos squared x, and folks, look at that. SQ is the square root of this, which is 2k cos x. Now, if you look carefully, that is exactly what they wanted us to show over there. Okay, so that was a little bit of trickery there that we needed to remember and make the correct choice with our double angle. Okay, so let's read the last part of the question. It's saying, now prove that SQ is 6x, 6 cos x over tan y. Now let's quickly go back to the diagram. There's y. It's lying in the right angle triangle. What am I doing? I'm finding the tan of y. So for 7.2.3, I think that is a good place to start. We're going to say in triangle PTQ, the tan of that y is equal to 3 over k. And that is because I have a right-angled triangle. Now, if we look at the answer contains a cos of x. There's our cos of x. And we want SQ, and there's SQ. So the only thing for us to do here is to get rid of the k. There is no k in the answer. That's the point here. Okay, so if we get rid of k, there we go. Where's the k? It's right over there. So I'm going to say, but what is k? K is SQ divided by 2 cos x. And therefore, the tan of y will be 3 over this thing over here, SQ over 2 cos x. We just formed an ugly fraction. We call these fraction complex fractions. So what am I going to do? I'm going to multiply this whole thing across to the other side, and I'm going to divide by tan y. You can see from the answer that's where we have to go. So I'm going to say, therefore, SQ divided by 2 cos x is equal to 3 over tan y And all that's left is to get SQ by itself by multiplying 2 cos x both sides. So SQ is indeed 6 times the cosine of x divided by the tan of y. Now, Smiley, thank you for that question.